viewers, welcome to my channel and thank you for watching the videos. In this video, question 6A 1997 complex analysis UPSC CSE maths. Find the Laurent series for the function e to the power 1 upon z in 0 is less than mod z is less than infinity. Deduce that 1 upon pi integral 0 to pi e to the power cos theta cos sin theta minus n theta d theta is equal to 1 upon factorial n for all n is this. So e to the power 1 upon z is analytic because we know this we can write as e to the power minus z, and e to the power minus z can be written as e to the power minus x plus iy, which we can expand with the help of Euler's theorem iy. So we can write down this as e to the power x with minus sign, so e to the power minus x into cos minus y cos minus y and plus I sin minus y. So we can write it cos minus y is cos y and sin minus y is minus sin y. So this becomes e to the power minus x cos minus y will become cos y and minus I sin y. And e to the power minus x is in multiplication, that is there. Okay, so we got e to the power minus x into cos y minus I sin y. This is e to the power 1 upon z value. So from here we can write down this is the real part. U is equal to e to the power minus x cos y, and here into e to the power minus x we got the imaginary part. So imaginary part is minus e to the power minus x sin y, which is equal to v. We apply Cauchy-Riemann equations. Del u upon del x is equal to e to the power minus x cos y with minus sign, and del v upon del y is minus e to the power minus x cos y. So both are equal. And second we find out del v upon del x, that is e to the power minus x sin y, and del u upon del y is equal to minus e to the power minus x sin y. So from here we got del v upon del x is equal to minus del u upon del y, and both the Cauchy-Riemann equations have been satisfied. Now we know that this is analytic because CR equations have been satisfied, and Laurent series we can write down sigma n is equal to 0 to infinity a n z to the power n. In simple form we can say that Laurent series is fa plus h is equal to a0 plus a1h plus a2h square, a0 plus a1h plus a2h square, and so on, infinite series. And second part will be plus a minus 1 upon h suffix. A minus 1 is in suffix minus 1 plus a minus 2 is in suffix upon h square plus a minus 3 upon h cube, and so on, h cube and so on. So this is the simple form where we have an is equal to 1 upon 2 pi I integral c closed integral c, and here we are taking closed integral as mod z is equal to 1, which is unit circle. We may take any another one also. Fz is e to the power 1 upon z minus a to the power n plus 1 z minus 0, because a is 0 here, because e to the power 1 upon z, so z is 0 dz. So this is our equation. E to the power I theta is equal to z, and dz is equal to I e to the power I theta d theta. But only thing we can say that e to the power 1 upon z is having an essential singularity at z is equal to 0. Little bit about singularities. When we have Laurent series, which is having analytic part, which is increasing order of powers, Taylor series, and another is in which we have inverse powers of z minus a. That part is called principal part. So if we have function is having fz is having uh, principal part only with finite number of terms, then we have poles. And suppose last one is a suffix minus n upon a upon z minus a to the power n. Last term is suppose a minus n upon z minus a to the power n, then it means pole of order n. And removable if function is not defined at that point but limit is defined, then we can define function at that equal to the limit of that function. It is removable singularity. If function is single valued and singularity which is not a pole or removable singularity, we call it essential singularity. And in essential singularity, suppose at z is equal to a, as in this case z is equal to 0, essential singularity is, in that case, principal part of the Laurent expansion has infinite many terms. So here also, if we see that expansion which we have got, it is having infinite many terms. That is the terms in negative exponent, or inverse of z minus a also we call. So we got dz this. So an we were writing 1 upon 2 pi I 0 to 2 pi, because unit circle, so unit circle will be 0 to 2 pi. E to the power cos theta minus I sin theta. This is e to the power 1 upon z value upon z plus z to the power n plus 1, because z minus 0 0 is there, so z to the power n plus 1, which is here e to the power I theta we have taken z, so e to the power I n plus 1 theta will be this value, z to the power n plus 1 into dz is equal to I e I theta d theta. Just simplify it and we see I cancelled out, and all cos theta sin theta we have written together, because this also can be written in the form of cos theta sin theta. I cancelled out and we have written it separately, that e to the power cos theta first term, e to the power minus I sin theta, and here e to the power I theta minus e to the power I theta and e to the power minus I n theta. So this we have taken in the term which is here. We can club because it is in multiplication, so we can write like this d theta. So here we can write e to the power cos theta, and this e to the power minus I we take common, and sine theta plus n theta is there. So we can write down cos minus sine theta plus n theta, which becomes cos sine theta plus n theta, because cos theta is equal to cos minus theta, minus I upon 2 pi, which is from here, and then we have integral 0 to 2 pi e to the power cos theta and sine theta plus n theta, because it is minus, so we have taken minus here. Sine minus theta is equal to minus sine theta. Now we say that there are two limits, upper limit is 2 pi, lower limit is, when we put the limits are 0 and 2 pi. When we put the limits, we think it of it another term g theta, so it will be e to the power cos theta sine theta plus n theta. We are considering this one. So when we put 2 pi, it becomes e to the power cos theta with minus sign, because this minus is there. It becomes e to the power cos 2 pi minus theta, which becomes cos theta, and sine 2 pi minus theta plus n 2 pi minus theta d theta. This is the value. So here it is sine 2 pi minus theta becomes minus sine theta. So this is minus sine theta plus 2 pi minus n theta. So we can write down, this becomes e to the power cos theta bracket sine minus sine theta minus sine theta, then plus n 2 pi minus theta. So 2n pi, and we have multiplied minus n theta. This is the term. So we get sine of minus sine theta plus 2n pi minus n theta. So what happens, it is basically sine n pi minus sine theta minus n theta. This is the value outside e to the power cos theta. Here e to the power cos theta. So this will be equal to, so suppose we take sine theta plus n theta as theta dash. So this term, if we take minus common, will be sine theta plus n theta, which is we are writing as theta dash. So this becomes sine 2n pi minus bracket sine theta plus n theta, which is theta dash, which will be equal to minus sine theta dash. So that becomes sine theta plus n theta, sine theta, which proof we can do by expansion, sine theta plus n theta into e to the power cos theta, and this is what we have written here, e to the power cos theta minus sign is there, sine theta plus n theta is equal to minus g theta, because g theta we have taken this much. So with minus sign it is minus g theta. So when we put 0 limit and 2 pi, this will be ultimately the term is 0. So the first term is remaining, an is equal to this much. Now we have to take or find a minus h, because we have to find a minus n, because in the question we have e to the power 1 upon z. So the principal part is there. And we can write a minus n. In place of n we have put minus n. This is a minus n, and e to the power 1 upon z. 1 is in analytic, this is principal part. Now both we can compare, because this a minus n is principal part and this is also principal part. We can compare. So when we compared, we have written this 1 upon 2 pi 0 to 2 pi integral e to the power cos theta cos sin theta minus n theta d theta is equal to 1 upon factorial n, because 1 upon z to the power n is not in an, it is the multiplication part. So now we write again cos 2 pi minus theta, we are taking same as we did earlier. So e to the power cos 2 pi minus theta cos sin 2 pi minus theta minus n 2 pi minus theta will be, as we did in earlier question, this also becomes sin 2 pi minus theta is, this will be minus sin theta, then minus 2n pi and plus n theta. And as we did earlier, that this is 2n pi with minus sign, we take common. It becomes cos e to the power cos theta is there into this cos sin, this becomes minus sin theta and minus 2n pi, and this becomes minus n theta. So we take minus as common, that will give cos minus theta dash. If we say the whole thing will be cos theta, so that will be, we are taking now cos 2n pi minus, we write here 2n pi plus sin theta, this becomes plus sin theta minus n theta. So cos, this we take out, because cos minus theta is cos theta. So this becomes cos 2n pi plus theta dash, this term, which is equal to cos theta dash. So sin theta minus n theta, this term, cos sin theta minus n theta into e to the power cos theta. Fine. Now this is equal to, because we can now double, because when we have put 2 pi minus theta, that is coming same. It means we can double the integral and half the limit to obtain. So 1 upon pi, instead of 1 upon 2 pi, we have changed the limits